Hi, I'm an old guy and I do maths. Now, there is nothing in my tutoring work that I get asked about more often than the elements of circular trigonometry. It may be because it's weird or, well, unusual compared to the the other sort of maths that people do at high school and university. Um, but it's old. It's kind of clever, and if you can get your head around it, it's interesting and it's fun. Um, I realize I may not be preaching to the converted. So what I'm going to do today is just go through how we find the common trigonometric ratios of 30, 45, and 60 degrees, sometimes written as pi on 6, pi on 4, and pi on 3. And basically how we find the sines, cosines, and tangents of these as exact values. And in order to do that, we need to construct two triangles. We're going to ignore this one because it's the more complex one. We'll take a look at this isosceles triangle. It's a right-angled triangle, sides of 1, 1, and the square root of 2. We get this number by way of Pythagoras, a squared plus b squared, square root thereof. And because these two sides are the same length, and we have a right angle here, we know that this angle in here is 45 degrees, or pi on 4. Okay, so what does this allow us to do? Well, it allows us to work out the tangent, the sine and the cosine of 45 degrees as an exact value. And so that's what we're going to do. So the tangent of 45 degrees is the opposite over the adjacent, 1 over 1. The tangent of 45 degrees is 1. The cosine of 45 degrees is the adjacent over the hypotenuse. It is 1 over root 2. This denominator is sometimes rationalized, and you might see this written as 2 root 2, but this is how it starts life. Adjacent over hypotenuse. The sine of 45 degrees is interesting. It's the same as the cosine. It's 1 over the square root of 2, opposite over hypotenuse, 1 over root 2. Okay, so that's how we get these. We draw up this triangle, and we simply apply the rules. Opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, SOHCAHTOA, which it may help if you see it written down here, SOHCAHTOA. Okay. You may be encouraged to remember these ratios in a long chart. I don't have that much memory space. I always work off the triangles. It's your choice what you do. Okay, so the second triangle yields more information. And this second triangle consists originally of an equilateral triangle with sides of 2, 2, and 2. 1 and 1, 2. And because it's an equilateral triangle, we know that this angle in here is 60 degrees. And if we cut this thing in half, we know that this angle here will be 30 degrees. So 30 degrees, pi on 6, 60 degrees, pi on 3. We can also work out this length here, the height of this thing. It is 2 squared minus 1 squared, square root thereof, Pythagoras. So we have a triangle where we know the angles, 60 and 30, and we know the lengths, 1, 2 and the square root of 3. So we can go looking for the exact values of the sine, cosine, and tangent of each of these two angles. Let's do 30 degrees first, this one up here. Okay, so the sine of this angle here will be the opposite over the hypotenuse, 1 over 2. The cosine of this angle will be the adjacent over the hypotenuse, root 3 on 2. The tangent of this angle will be the opposite over the adjacent, 1 on root 3. Moving to this angle, which is 60 degrees, pi on 3. The sine of this angle will be the opposite over the hypotenuse, root 3 on 2, opposite over hypotenuse. The cosine of this angle will be the adjacent over the hypotenuse, 1 over 2. And the tangent of this angle will be the opposite over the adjacent, root 3 over 1, or simply root 3. So, that in not quite a nutshell is how we arrive at the exact values for this set of angles. And what we can do once we're comfortable with this is we can use these to go all the way around the unit circle and, for instance, without too much effort, for instance, find the tangent of 330 degrees, which may sound a little challenging now, but you'll see in the playlist that there's a video on that. So get your head around this, get comfortable with this, and move on to the next thing. Thanks very much for watching. See you later.